Hello everyone, my name is Zubair Mohammed and I'm from Team GG Incorporated. This is our submission for the Walmart Sparkathon. So a little bit about our problem statement. What we are basically doing is we are optimizing the supply chain using generative AI. In order to do this, we are using a technology called Retrieval Augmented Generation, also known as RAG. So what basically RAG does is it will help us improve the efficiency of fulfillment centers as well as distribution centers by basically executing complex instructions and then splitting that complex instruction into simpler instructions that can be understood by the robots. For example, here we have a human. What basically the human is saying is that we want to move food items from shelf A to shelf B. So in order to do this, we basically use a large language model, that is Llama 3. We provide the model with some context. This can be from the database as well as from a PDF document relating to the stock. Next, the Llama 3 interface basically splits the task into several subtasks that can be understood by the robots. For example, move to shelf A, then pick the items, then move to shelf B and put the items in the appropriate shelves. So once that is done, what basically happens is that these subtasks are sent to the robots, and using RAG again, the robots are picking the most optimal task for them. For example, this robot right here, it will be picking up the bread and eggs, whereas another robot right here, it will be moving the butter to the cold storage. This can be basically done dynamically using RAG. So for a demo, we have a simulation of the warehouse, which is utilizing Unity as well as Python. Let me show you. So here we have the warehouse simulation in Unity. So we can toggle between the different cameras of the robots in order to see the warehouse. So in order to basically trigger the actions, what we are basically going to do is we are going to run the Python backend. Now we are going to provide it with an instruction. For example, let's say we have to get tomatoes. Now this instruction is being sent to the large language model where it is being processed, and it will be returning different instructions that are needed to run robots. Once the instructions have arrived, we can see the robots are in action, and the robots are moving to the destinations, which are to the locations of the different tomatoes. For example, this robot right here, you can see that this robot has gotten tomatoes and will be returning back to its docking station. So this was it for the demo. Thank you very much.